Hello and welcome to my YouTube channel. My name is Kaushik Roy. Do you know how a machine learning model recognizes a speech, an image, or a text? In our example, we'll take the handwritten letters. How do we recognize these handwritten letters? For example, 0, 1. We'll go to its mathematical derivations and we'll derive the formula for cosine similarity. Here, let us take two vectors, r and s. This is vector r and this is vector s. The difference between these two vectors is r minus s. Let us understand that the angle between these two vectors is theta. Let us draw a perpendicular line on s, and this part is r mod cosine theta, and this part is r mod sine theta, and this part is s minus r cos theta. From the Pythagoras theorem, we can write r minus s whole square equal to r sine theta plus s minus r cos theta whole square. We can expand the left hand side as this. And the right hand side is r mod square sine square theta plus s square minus 2s r cos theta and plus r square cos square theta. We can simplify this by taking a common of r mod square, and inside the bracket we get sine square theta plus cos square theta. As sine square theta and cos square theta is 1, we can simplify it as simply r squared. Now, if I compare the both left hand side and right hand side, we see that 2r dot s is equal to r s mod cos theta, and r dot r is nothing but r square, and s dot s is nothing but s square. By comparing both sides, we can write 2s mod and r mod cos theta equal to 2 r dot and s dot. From this, we can find it out cos theta equal to r dot s dot divided by r mod and s mod. This formula is for cosine similarity between these two vectors r and s. Cosine similarity determines whether the vectors are similar or not. Cosine similarity becomes highest when the angle between these two vectors are 0, and the lowest when the angle between these two vectors are 90 degrees. Now, we'll be jumping into the coding part of it. We'll be implementing it in the Python. First step, we'll be installing the two packages. NumPy and Matplotlib. NumPy is used for numerical calculations, and Matplotlib will be used here for plotting purpose. In the second step, we define three vectors: A, which is 2, 3, B, which is 6, 5, and C, which is 4, 1. And all the vectors starts from the origin 0, 0. In the next step, we'll be plotting those vectors. We'll be using plot function and label them with A, B, and C. A vector is marked in blue color, B in orange, and C is in green. Here, we can observe that the angle between A and B is this, and the angle between B and C is this. And also observe that angle between A and B is smaller than angle between B and C. In step 3, we'll be defining two functions. One is to normalize the vector, and another is cosine similarity. We normalize the vector by dividing the vector by its length. We find out the length by summing up the square of each of the elements of the vector and taking it square root. X dot x is same as summations of the squares of each of the elements. We're using the NumPy package np.sqrt to square root it, and then dividing the entire vector with this scalar value, which is the length of the vector. Next, we are defining the cosine similarity function. It takes two vectors, x and y. We find out the dot product between x and y, which will be our numerator as part of the cosine similarities function. And then we find it out the length of x vector by summing up the square of each of the elements and then taking the square root of it. The next step, we're finding the length of the y vector in a similar way, and we're using the formula of cosine similarity to find the value of cos theta and returning the value of cos theta here. In step 4, we'll be deriving the cosine similarity between its vectors A and B and also the vector B and C. From this diagram, we see that A and B is much closer, so cosine similarity will be higher than the cosine similarity between B and C. We have found out the cosine similarity between A and B is 0.9587, whereas cosine similarity to B and C is 0.9, and between A and C is 0.73. As vector A and B is much closer compared to B and C, that's why the cosine similarity between A and B are more than cosine similarity B and C. At the same time, the vector A and C is far away, and that's why the cosine similarity between A and C. For our example, I have already installed them. Here, we are importing MNIST dataset, which has 70,000 handwritten digits for machine learning algorithms training purpose. We'll be using this dataset for our simple cosine similarity calculation. We are loading the data, train and test, and then checking the shape of it. In our example, we do not need train and test. We just need one data set. Here, we are displaying the handwritten digits, the very first 25 handwritten digits. We can observe here, the first digit is 5, then 0, then 4. Similarly, the other handwritten digits are, for example, 1 and 5. Now, we'll be trying to find it out, the mean image for each of the digits, for example, 5. We'll add up all the image values of 5 and then divide it by number of image value. Similarly, for 1 and other digits, we're defining a variable means which will include the mean image of all the digits from 0 to 9, then applying a for loop for each of the unique digits, adding up the image pixel values, and then getting its mean using only trained data set. We want to see how does the mean image look like. We have displayed here the mean image of 1, though different people have written 1 differently, but the average 1 is like this. Similarly, we have displayed 5, though different people have different handwritten 5s, but if we add up all the 5s, we'll be able to find out this image. Now we'll try to find out the cosine similarity, and to do so, we first flatten the image, which is a 2 by 2 matrix. If we use the functions ravel, it will flatten the 2 by 2 matrix image to a single dimensional image and will make it a vector. We have two images, the image 0 and 5. We have made it a vector and passing it first to the normalized vector and then to the cosine similarity function. We can see the cosine similarity between digits 0 and 5 is 0.84. We can see the cosine similarity between digit 1 and 5 is 0.65. We are trying to find out a cosine similarity which is highest.